Today we're going to learn about geometric sequences and series. A geometric sequence is a sequence whose consecutive terms have a common ratio we call R. A sequence is geometric, I need to correct that on your paper. A sequence is geometric when the ratios of consecutive terms are the same. So the sequence, a sub 1, a sub 2, a sub 3, etc., is geometric when there is some number r such that if you take any term and divide it by the term in front of it, you get the same thing every time, no matter which term you choose. If you take any term and divide it by the term in front of it, you get the same number. To find r, then, in any geometric sequence, take any term, divide by the term in front of it, the preceding term. Let's write the first four terms and find the common ratio. In the geometric sequence given by a sub n is 3 times 2 to the n. So the first term is when n is 1. If I put 1 in for n, I get 3 times 2 to the first. If I am finding the second term, I'm putting 2 in for n, so that's 3 times 2 to the second. The third term will be 3 times 2 cubed, and the fourth term will be 3 times 2 to the fourth. That makes our sequence 3 times 2, 3 times 4, 3 times 8, and 3 times 16. R here, what are you multiplying by each time? You're multiplying by 2. To get to any term, you multiply by R. Okay? Number 2, write the first four terms and find the common ratio of the geometric sequence given by this one. So we'll do this the same way. To find the first term, we put 1 in for in for n, so we get 4 times 3 to the first. For the second term, we'll put 2 in for n. Third term, 3 in for n. And the fourth term, 4 in for n. So 4 times 3 to the first is 12. 4 times 3. 4 times 9 is 36. 4 times 27. 4 times 27 is 108. 4 times 3 to the fourth. 3 to the fourth is 81, and 4 times 81 is 324. What are you multiplying by each time? 3. It's easy to see what r is because r is always the base of your exponent. Okay? Your base of your exponential term, I should say. So what will r be in this next one? R will be negative 1/3. We'll multiply by negative 1/3 each time. So the first term is when n is 1, so that will be negative 1/3 to the first power. Yeah? So the very first term is negative 1/3. What do you get when you multiply that by negative 1/3? Well, you're going to get a positive 1/9. Now multiply that by negative 1/3. That by negative 1/3 will be a negative 1 over 27. And one more time, this will be a positive 1 over 81. You're multiplying the top by 1 and the bottom by 3. So each of those terms is getting very small, or much smaller. Okay. The sequence given by 5, 10, 20, 40 is geometric with a common ratio of 2. If you take any term and divide by the term before it, you get 2. Another way to think of this is, what do I multiply each term by to get to the next term? That's your r value. To write a formula, an explicit formula for how to find any term in the sequence, we can think. If we start with 2 to the n, we could start with 2 to the n since the common ratio is 2, but it is more convenient to start with the term 2 to the n minus 1. That way, when n is 1, we'll have 2 to the 0, which is just 1, so we can just multiply that by whatever the first term in our sequence is. Okay, so for this one, the first term is 5, and then our common ratio is 2. If we multiply 5 by 2 to the n minus 1, we get our formula. So we can think of a formula for finding the nth term of any sequence like that. And then you can always manipulate this if you want or need to. If you have r to the n minus 1 power, that is r to the n times r to the negative first, because we add exponents. And this is r to the n times 1 over r, so that's r to the n over r. So we can manipulate this any way that we want. Alrighty, let's do some examples. Should have stapled these together before I started this video, but that's okay. Alright, let's write the explicit formula for the nth term of this sequence. So here's my thought process. This is my first term. I think this is exponential. A geometric sequence is very comparable to an exponential function. So my first term is negative 27, and then I'm multiplying that by my r to the n minus 1. Okay, this will be my a sub n formula. What is my r? Take any term and divide by the term in front of it. It's going to be easiest for me to go to these smaller numbers. I'm going to take negative 8 and divide by the term in front of it. Well, the negatives reduce out, and this reduces to 2/3. So my r is 2/3. Okay, so this is my formula to find any term. They asked me to find the 8th term, so I'm going to put 8 in for n. My power will be a 7 there. So this is negative 27 times 2 to the 7 over 3 to the 7. Let's reduce that. We're not going to have a calculator, so let's reduce this. 27 is 3 cubed. So this is negative 3 cubed times 2 to the 7th over 3 to the 7th. The 3 cubed and the 3 to the 7th reduce, and we're going to have negative still, 2 to the 7th over 3 to the 4th. 2 to the 7th is 128. 3 to the 4th is 81. So the 8th term in that sequence is negative 128 over 81. Next up, let's write at the explicit form, do the same thing. For the geometric sequence with first term negative 3 and common ratio negative 2. So the first term is negative 3, the common ratio is negative 2. So this is our formula for the nth term, any term in the sequence. They ask us for the 11th term. So the 11th term will be, we're putting 11 in for n, so this is 10. This is negative 3 times a negative 2 to the 10th. Since we're raising a negative to the uneven power, this will be positive. And 2 to the 10th is 1024. If I multiply that by 3, I get negative 3072. Number 6. The second term of a geometric sequence is 20, and the fourth term is 180. What is the first term if every term is positive? Well, if every term is positive, then I know that my r has to be positive, first of all. Okay? So let's think about this. Our second term is 20, so we have some term, then we have 20, and then we have another term, that will be our third term, and then we know that our fourth term is 180. If I multiply by r twice, I should get to 180. So 20 times r squared must be 180. That means r squared must be 9. Divide both sides by 20. And that tells me that r has to be 3. Positive 3 because every term is positive. Positive 3 because every term is positive. So, how do we find the first term? Well, the first term multiplied by r will get me to my second term. And I know my second term. So my first term multiplied by 3 must be 20. So my first term must be 20 over 3. Number 7. The fourth term of a geometric sequence is 125. The 10th term is 125 divided by 64. What is the 14th term? If this series is alternating in sign, well, if it's alternating in sign, I know that my r must be negative. Just like above, if a was always positive, I know that r must be positive. Okay? All right, we have our fourth term is 125. How many r's do we have to multiply by to get to the 10th term? To get from the second to the fourth, we had to multiply by r squared. To get from the fourth to the 10th, how many r's do you multiply by? 6. So 25r to the 6th must be 125 divided by 64. So r to the 6th must be, if you divide both sides by 125, you're going to get 1 over 64. 6th root each side. What's the 6th root of 1 over 64? 1 over 2. But it's negative because we are alternating inside. It would be plus or minus. You keep the negative because we know we're alternating in sign. So to find the 14th term, well, if I take the 10th term and multiply by 4 r's, I should get to the 14th term. So 125 over 64 times negative 1/2 to the 4th should be the 14th term. So my 14th term is 125 over 64 times positive 1 over 16, and that is 125 divided by 64 times 16 is 1024. I came off to the side and multiplied that earlier. I couldn't do that one in my head. I could do the other ones we've done in my head, but not that one. Okay. Let's consider this finite series. So if I take just the sum of the first n terms in the sequence, if the series is geometric / sequence, if it's geometric, then I know that a sub 2 is a sub 1 times r. A sub 3 is a sub 1 times r squared. A sub 4 is a sub 1 times r cubed, etc. So a sub n will be a sub 1 times r to the n minus 1. If I take that equation and multiply both sides by r, I'm going to get r times s sub n is equal to a sub 1 times r plus a sub 1 times r squared plus a sub 1 times r cubed plus a sub 1 times r to the 4th plus ... This last one will be a sub 1. If I multiply it by another r, I'm going to get r to the n there. Now we're going to subtract the second equation from the first equation. So I'm going to come in here and we're subtracting these two. So I have, on this side, I have s sub n minus r times s sub n. If I'm subtracting these, that's going to subtract out to 0. This is going to subtract out to 0. This is going to subtract out to 0. All of these are going to subtract out to 0. This one is going to subtract out to 0 with the one that came before it. So I'm going to be left with this one and this one. So I'll have, this is equal to a sub 1 minus a sub 1 times r to the n. I'm going to factor an s sub n out of these first two. And that will be, if I take an a sub 1 out of both of these, we get that. And now if I solve this for s sub n, I'm dividing both sides by 1 minus r. I get a sub 1 times 1 minus r to the n divided by 1 minus r. Another way to write that is a sub 1 times 1 minus r to the n divided by 1 minus r. This is our formula for the sum of the first n terms of any series. I need you to have that memorized. So find a way to memorize that one. Okay? Let's do some examples. Let's find the sum of n equals 4 to 14 of 2 to the n minus 1. So we need the first term of this series. So the first term is 2 to the, we're putting 4 in for, we have to put 4 in for the n to be the first term of the sequence, of the series, I mean. That's 2 cubed, which is 8. So the first term is 8. Okay? Now we also need, for our formula, we need to know what r is. What is r? Well, r here is 2. It's always very easy to see in a geometric formula. We also need to know what n is. How many terms did we sum up here? And as we learned previously, to find how many terms you're summing up, we take the top number 14, subtract the bottom number, and then add 1. 14 minus 4 is 10, add 1, and we get 11. There are 11 terms that we are adding up. Now we take these two and go to our formula. The sum of the first 11 terms is the first term times 1 minus r to the n divided by 1 minus r. If you do lots of examples, if you do lots of practice, you'll have that formula memorized without even trying. If you don't do your homework, you're going to have to work to memorize that for the test. Okay, let's clean this up. 1 minus, 2 to the 11. 2 to the 11 is 2048. If you don't have that memorized, go off to the side and multiply some 2's together. On the bottom we have a negative 1. That negative 1 is going to make this, 8 divided by negative 1 is just a negative 8. And then we have 1 minus 2048, that'll be a negative 2047. When we multiply those together, we get a positive, and that turns out to be 16,376. I multiplied that out a little earlier. Okay, by the way, let's check this answer. On your calculator, there is a function. You will not have a calculator for the test, by the way, so you can't do this on the calculator, but it's a good way to check your answer. Under F2, under F2, so alpha F2, The second one down is the summation. So I'm just going to hit the number 2. My variable, instead of calling it an n, as in my problem, I'm going to call it an x just because it's easier to reach. And then 4 to 14 of 2 to the n minus 1. And we get this. So we checked out. I know I'm right. Okay? Alrighty. Number 9. Let's find this sum. So we always need our first term. Our first term here is 1/2 to the 1 power. Always take your time and put that number in for your n and work it out. So this is just 1/2. What is our common ratio, our r? Well, our r is 1/2. How many terms are there? Well, 10 minus 1 plus 1 is 10. There are 10 terms there. We'll take this information and go to our formula. The sum of the first 10 terms is the first term times 1 minus r to the 10th power divided by 1 minus r. Let's clean this up. This is 1 minus 2 to the 10th is 1024, and I'm dividing it by 1/2. Okay, this 2 times 1/2 is just 1. 2 times 1/2 is just a 1. And so this is, this part cancels out. So all I have is 1 minus 1 over 1024. Let's get a common denominator. The common denominator is 1024. So 1 is 1024 over 1024 minus 1 for the other fraction. This is 1023 divided by 1024. Let's check that one on our calculator. Get to where there's no glare. It's hard to find a spot with no glare here. There it is. Okay, I'll clear that one out. So alpha f2, number 2. X from 1 to 10 of 1/2 to the n power gives me that decimal. I'm going to change that to a fraction. So math 1, enter, and there's my answer. So that one checked out too. That's good. Alrighty. Let's consider our formula for the sum of the first n terms of a geometric series. If r is a small fraction between -1 and 1, what happens to this formula? As n gets very, 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 very large, what happens as we let n go to infinity of this formula? Well, as n goes to infinity, we don't get the partial sum anymore, we get the infinite sum. We get an infinite sum, okay? And our fraction is 1 minus r to the n over 1 minus r. R is between -1 and 1. It's a small fraction, and if you raise that to a huge, huge number, this gets teensy, teensy tiny. It approaches 0. Think of 1/2 to a large number. If you take 1/2 to a very large number, even if I just do 10, look how small it is. That's 0.00097, and that was only with an exponent of 10. If I take 1/2 and raise it to the 100th power, that is 7 with 31 zeros in front of it, or 30 zeros in front of it. It's a teeny tiny number, Okay, so this gets really, really, really small. It's negligible. As n goes to infinity, that becomes negligible. So I just have a sub 1 times 1 minus r, which is a sub 1 over 1 minus r. So as n goes to infinity, if r is between -1 and 1, then we can actually find the value of an infinite series, this infinite geometric series. We could not do that with an arithmetic series. Okay, so this is our first term. Remember, key to remember is that in this formula, that a that's on top is always whatever the first term in your series is. So we will carefully plug in the index, the first index number, to find that first term. Let's do a couple of examples here. Let's find the sum of this series. So all we need to know is our first term and our r. The first term here, if I plug in 0 for n, I'm going to have 3 times 1/2 to the 0. 1/2 to the 0 is 1. So our first term is just 3. Our r is 1/2. It's the base of our exponential term. So my infinite sum, we just call it s. S stands for the infinite sum. There's no subscript. If there was a subscript, you would write infinity down there. Okay, this is our first term divided by 1 minus r. Oops. R is 1/2 here. Okay, I'm going to multiply top and bottom by my small denominator, and I get 6 divided by 2 minus 1. 2 minus 1. So that's just 6. So this is 6. Let's do another one. Let's find the sum of this series. What's the first term? The first term is what we get when we put 5 in for n. So it'll be 81 times 1/3 to the 5 plus 1. 81 is 3 to the 4th. And 3 to the 4th divided by 3 to the 6th is 1 over 3 squared. That's 1 over 9. So our first term is 1/9. Our r is 1/3. It's the base of the power of the base of our exponential term. So the sum of this infinite series is our first term divided by 1 minus r. I'm going to multiply it by 9 over 9 this time because 9 is my bigger number there. 1/9 times 9 is 1. 9 times 1 is 9. 1/3 times 9 is 3. So this becomes 1/6. So this sum is 1/6. Number 12. Find the sum of this series. Well, the first thing I notice about this series is that r is 5, and 5 is large. 5 is too big to find the sum. The absolute value of 5 is greater than 1. Therefore, this series is going to get, each term is going to get bigger and bigger and bigger and bigger. There's no way to find the sum. No way to find the sum. So this series, we call this series diverges. That's what we call it when a series gets bigger and bigger and bigger and never converges to a single number. So this series diverges to infinity. Okay, for the next one, I see that we have our r is e over pi. E is 2 point something, pi is 3 point something. So this is less than 1. So we are good with moving forward and finding the sum. What is our first term? Well, our first term is 2e times e over pi to the first power. That is 2e squared over pi. So our sum is our first term divided by 1 minus r. I'm going to multiply top and bottom by pi to get rid of those little pi's. I'm going to have 2e squared on top, and I'm going to have pi minus e on the bottom. This is our sum. And that is geometric sequences and series.